My name is Jesse Anderson, and I'm an instructor, and I teach big data concepts as well as Hadoop and Spark. In this video, I'd like to teach you about HDFS. We're actually going to do this in a very innovative and very hands-on way. We're actually going to be using Legos. But to start off with, let's talk a little bit about what HDFS is. It is a purpose-built file system. It is purpose-built to handle the needs of big data, where that brings in a few different changes. So Hadoop, or HDFS, stands for Hadoop Distributed File System, where a distributed file system functions a little bit different than other file systems. It also has some caveats as a result of that. One of those caveats is that the files are immutable. That means that when you're writing a file and you close that file handle, you can't go back and change that file anymore. That file is now read-only in another sense. It's also purpose-built to handle big data. In other words, if you're going to fill your hard drive or fill your disk with a bunch of small files, that's going to make a very poor use of your data. Those 1K files, you probably don't want to have those in HDFS. What you're going to want is to aim at 1 gigabyte or so files. As you can see, I have several different pieces of paper in front of me, as well as some Legos. Each one of these pieces of paper represents something different. And these 4 pieces of paper represent computers or nodes within my cluster. This is node 1, node 2, node 3, and node 4. This node is responsible for coordination, and we're going to give names and we're going to talk more about what these do in just a second. But now let's focus on the Legos. These Legos, each one of these Legos represents a file. For example, this is a red file, this is a yellow file, and this is the blue file. In this red file, we're going to say that this is 128 megabytes. This yellow file is 132 megabytes, and this blue file is 32 megabytes. As you can see, each one of these files is a little bit different, and it's colored different, so that we can see that and visualize how the files are laid out within our cluster. One of the things that HDFS does different is instead of dealing with a file, 128 megabyte file all at once, what it does is it breaks it up into what are called blocks. So this 128 megabyte file becomes 2 blocks of 64 megabytes each. This block is 64 megabytes and this block is 64 megabytes. In this block, the red file, we have several different pieces, and as we start to go write this out into our cluster, HDFS does another thing. It actually creates replicas for us. We'll talk about the reasons for the replicas later on, but suffice it to say this replica is important. Now, as we go to put this file into our cluster, what we do is we take this block, and by default it's going to be broken up 3 times into 3 separate replicas. So here we have one of our replicas is going to exist on node 1. Another replica is going to exist on node 3, and another replica is going to exist on node 4. Looking at our cluster, we have 3 replicas of the first block of the red file. Now let's do this with the second. The second block gets replicated here on node 2, on node 3, and node 4. As you can see, this entire file is replicated 3 different times. Here on node 1, we have block 1, block 1, block 1, 3 times. Then we have block 2 replicated 3 times as well. Now let's see how we deal with a file like yellow file. In this yellow file, you remember it's a little bit different. It's not exactly 128 megabytes. We have a little bit here on the end. So now what we do is when we go to break this file up into blocks, we're going to have 3 blocks now instead of 2, because our file is a little bit bigger. It's 132 megabytes. So here we have one replica, one block, another block, and another block. Let's replicate this file around the cluster, just like we did with the red file. Here, it gets broken up for us, and The yellow file, block 1, is replicated all around the cluster. Now let's do the same with the second block. And as you can see, this smaller replica, or smaller block, doesn't actually extend out to the 64 megabytes. When we have a smaller end piece or a smaller file, that only occupies as much data as it needs to. So this third block is going to be replicated around our cluster, like so. As you can see once more, the yellow file is replicated in its entirety 3 times on different nodes within our cluster. We have block 1 here, we have block 2 on these nodes, and we have block 3 on these nodes. Now let's see how we can write to the cluster. We're going to write our blue file to the cluster. And as part of this, we're actually going to start talking. We're going to start saying to this node, and it's going to help us coordinate things. And that coordinator is going to tell us, okay, I want to write a blue file to the cluster. And the coordinator is going to come back and say, write that file to node 1, 2, and 3. So what we do is here in our cluster, when we start working with that, the first replica is going to be placed on the first node. And then, remember how the coordinator told us to go into 2 other nodes? What's going to happen is, I as the client talk directly to node 1. Node 1 is then going to talk to node 3, and it's going to replicate that data over. And then node 3 is going to replicate that data over to node 4. And this is what's called a pipeline. The pipeline goes like this. One of the important parts or distinctions for HDFS is that I as the client, as I'm writing out this data, the data, as soon as it is written its entirety to the first node, it is going to respond back and say, okay, your data has been written, whereas there still may be that pipeline transaction going on in the background. Now, let's say we want to read that file. Let's say we want to read the blue file now that we've written it. The first thing we have to do is we have to talk to our coordinator node. And we say, coordinator node, where is the blue file at? I'd like to read it. And the coordinator node is going to come back and say, it's on node 1, node 3, and node 4. And as that data comes back, as that information comes back to us, that node is going to tell us in the order that we should prioritize it from. So we're going to read from node 1, and we're going to read that data back. Notice that there are very separate things that are happening, where when we try to figure out what's happening within the cluster, we have to talk to this coordinator node first. We have to say, where are the places where we could read the blue file from? But once we start actually trying to pull that data and start working with that data, we talk directly to that node. We don't want a single node within our cluster having to have all this data go through it. That becomes a bottleneck for us. Now that we've seen a little bit more about how this reading and writing happens, let's see let's talk a little bit about these functions and these daemons in more depth. In this example, we have 4 different machines. And remember, you've seen these machines, they've been responsible for reading data as well as writing data, writing out these blocks. And the daemon process that does that is called the data node. The data node daemon is responsible for reading blocks and writing blocks. Then we've also seen how we have this coordinator node, and whenever I want to find out something that's happening within the cluster, I have to talk to it. That's called the name node. And the name node's responsibility is knowing what's happening and coordinating what's happening throughout the cluster for HDFS. As we just saw, whenever I wanted to read a file, it's the name node's job to know that where each file is and which block, so on and so forth. There's a lot of information that it handles. So once again, that coordinator is called the name node, and then the daemon process is the daemon process for these nodes is called the data node. That data node process, once again, is responsible for reading and writing of blocks. We talked a little bit before about how everything is replicated 3 times within our cluster. Now let's talk about why that's important. In this case, we want to have 3 different replicas. And we'll talk, here's an example of why you'd need that. Let's say the Hulk comes into your data center and smashes data node 3. Data node 3 is now down, but it was storing several different blocks in it. As we can see, there's some blocks that are what are called under-replicated, and some blocks are okay. For example, we have yellow block 3 is completely replicated. It's replicated 3 times still. It's replicated here, here, and here. However, other blocks are now under-replicated, meaning that they aren't replicated 3 times. For example, yellow 1 is only here and here, and yellow block 2 is only replicated here and here. Only a total of 2 times. We want 3 times. What's going to happen is that the name node is going to realize that data node 3 is no longer with us. It's no longer working. And what it's going to do is it's going to instruct the other nodes and say, you have a particular block. I want you to replicate that to another node. So let's actually do that. So as we were talking about, yellow block 1 is now under-replicated. What's going to happen is the name node is going to tell data node 2, replicate that block that you have, block 1, over to data node 4. And now that data in its entirety, you remember how I talked about that the data for these blocks are in their entirety? They're not a checksum or something like that. They're actually, that allows us to copy the data from here over to here and create another copy of it in its entirety. So for the purposes of time, I'm just going to do this very quickly and manually. And you're going to see that I'm moving these blocks that were under-replicated before to new nodes. So these new nodes allow us to see that we're back to having all of our blocks replicated again. This is a process that the name node handles for us and does automatically behind the scenes. So whereas some of the things were under-replicated now, we now have, for example, the blue file in 3 different places. There's another important concept that we need to talk about of reasons why we have 3 replicas, and that's called data locality. Whenever we want to run a MapReduce job, specifically the map portion, we want to be able to access that data locally on that system, where if the data does not exist locally on that system, it will have to be pulled across the network to that node and be processed. This is very important because as jobs are being run for us, what's going to happen is the priority is going to be given to those nodes that actually contain that data. For example, if I were to run a MapReduce job over the blue file, when that MapReduce job is run, it's going to say, I really prefer that you run that job on node 1, node 2, node 3. And let's imagine we had 10 other nodes over here. We would say, we really don't want to run it on those. We really want to run it on these 3. And we give a higher priority for that. We do that once more because this node is able to read that very quickly. It's going to read it over that vast SATA drive that we have local to that machine, instead of having to read it across the network from a different machine. This also comes into play when we have other daemons that are located right there with our data node. One good example of this is HBase, where HDFS works a little bit different with HBase, whereas data is written with HBase, when it is located with a data node, the first replica is always written locally to itself first. And as a result of that, it gives you some speed improvement and performance improvement by not having to read across the network. As that first replica is written locally, it's also written to other replicas in the background onto other nodes. Well, I hope this video helped you understand some of the details and some of the ways that HDFS works. If you'd like to see innovative ways of learning, such as this, where we're using Legos in order to see how all this works for us, then click on the link that's in the description, and we'd love to talk to you about more.